Hi, and welcome. This video presents how each developer can create a private instruction set for the compiler and compile encrypted bytecode which can only be executed by a private virtual machine. A simple Hello World example is used to explain how to integrate SCRAMBLECODE with a C# application, and finally, just-in-time deployment is presented. SCRAMBLECODE provides each customer with their own private list of instructions for the compiler. Every instruction set is unique. This is ensured by having each customer create an asymmetric key pair that takes part in the definition of the instructions. The SCRAMBLECODE IDE includes a wizard for generating key pairs. When SCRAMBLECODE compiles your source code, it generates encrypted bytecode instructions which can only be executed by a virtual machine that understands the instruction set. The compilation is done in 3 steps. First, the source code is processed and converted into anonymous symbolic structures by removing all metadata. Then the compiler generates the private assembler, which is targeted exclusively to your VM. The assembler instructions are then scrambled, intertwined, and bundled into larger encrypted entities. This ensures nobody can crack and modify an instruction without having to change perhaps thousands of other encrypted instructions as well. Finally, the generated bytes are signed and sealed with a private key, which is the secret part of an asymmetric set of keys created by you. This generates the compiled bytecode that is ready to be loaded and executed by the virtual machine. The generated bytecode is stored as a base64 formatted text string for easy handling. It can be saved to a file or copy and paste it into your host application. It is possible to have your application create and execute a VM, which can then create and execute another. This can continue within a single thread. It is also possible to create and run virtual machines in parallel using multi-threaded execution. The responsibility for loading and executing all these virtual machines is taken care of by the SCRAMBLECODE VM library. This is often referred to as the VM DLL. This library implements a very simple application programming interface which allows a host application to easily load and execute many virtual machines. Each customer can build a VM DLL for a given key pair. This is known as creating a target. The VM DLL will have the public key embedded inside the library to authenticate the loaded bytecode before execution, whereas the corresponding private key is kept secret within your organization. The SCRAMBLECODE IDE has a target form to create VM DLLs. Here we have created 4 targets, 1 target for each of the 4 key pairs included in the evaluation license file. You can do this too. When you create a target for your own keys, you can create both a 32 and a 64-bit DLL for royalty-free deployment. Once your targets are ready, you can select a target as part of the project properties and now compile your project to use instructions that are only understandable for the targeted DLL files. The most important API functions are the VM create, VM execute, and VM free. It is always your host application which loads the first VM, and this virtual machine can then create others. The documentation describes all API functions in detail as presented here in the online version. A C# class for .NET is included to demonstrate how to encapsulate all API functions and make them available in a very simple high-level format. Even if you're not using C#, this simple class can serve as an inspiration for an easy integration of the SCRAMBLECODE API for your programming language. Let's have a look at a simple Hello World example. Our host application made with C# for .NET will execute the SCRAMBLECODE source code presented here as encrypted bytecode in a virtual machine. Before execution starts, the compiled bytecode is saved in C# as a base 64 formatted string using just a simple copy-paste operation. The C# code uses the previously mentioned .NET class to call the DLL API functions. It starts by creating a new VM, passing the bytecode as a string argument. The bytecode signature is authenticated and a VM handle is returned. The VM execute API function invokes the mandatory main function of the main class. Due to the arguments, the bytecode writes the hello world string to a VM cell and returns. Please note, each VM has a memory area called VM cells. Working with these is analog to using the cells of a spreadsheet. Each cell is identified by a row and a column number. VM cells can contain strings, integers, or byte arrays. It is possible to transfer thousands of values back and forth between the host and the virtual machine, or from one VM to another. VM cells can be used in random order and for data tables and values of random size. You completely avoid having to push and pop stack values. Finally, the C# code just reads the string value and presents the message box, and then ends by freeing all resources and cells of the VM. This was a very simple Hello World example, but the documentation includes a more sophisticated and relevant example that demonstrates how to protect some sensitive data, perhaps a license file, with an RSA signature in C# and then use SCRAMBLECODE to authenticate the signature in protected bytecode. This example involves creating and working with public-private key pairs, and you learn to deal with big engine and little engine byte order issues. It is a real-life scenario that presents some interesting and relevant code to get you started using SCRAMBLECODE and C# together. Solutions with your generated DLL files can be permanently deployed royalty-free to your customers. The binaries are self-contained and can be X-copied with no external dependencies. The SCRAMBLECODE protected bytecode can be permanently deployed as well, but it can also be delivered as text in a web response, which allows for just-in-time deployment of the latest version right before code execution begins. Thank you for watching this video. More information is available at scramblecode.com.